Hey, so one of the more challenging things to do is to take a list of objects and say that we want to filter them based on multiple potential filters we want them to match up on, right? Like we want them only where like everything where the key is going to be a certain value, except we want to have multiple values and we want to do that in a somewhat performant way. So if we were to sort of look at this in terms of what inputs would look like for that, we could have like a list of objects with, their objects, each of which are just gonna be little key value pairs, right? K of A, value of X, key of C, value of Y, K of D, value of Z. And maybe there are a bunch of keys that we want to be able to map it with. And this is a generalized problem, right? So like this could be any number of types of data that we might want to work with. So we might say we want to identify a certain key, and we're going to say that if that key is in one of these, then we would like it to filter just to that particular list. Now, in code, this is something that's actually relatively straightforward to do through like a generalized array function. This is part of functional programming. To do this in sort of a no-code environment like Xano, we do it a little bit more from first principles. So the idea is we're not actually going to modify this existing array because it's going to be an input to the function. We're going to create a new one that will only have our filtered list. Now, to do this, we're going to need a few things. We're going to need to know what are the objects, what are the keys, and what's the path to that key. And we're going to create a new list, right, of objects will actually contain all these guys. That's going to be that's the output here. And then what I usually do is I loop over the filtered list, right? The list of good keys, because that's usually a shorter list. It's going to make the thing run a little bit faster. And so I'm going to say I'm going to loop over each of my keys, and I'm just going to call that key for a second. And that way, if I were to, quickly give this a little, utility and stop and debug, always my favorite function, I could say that the current key that I'm looking at, and if I were just to run that guy for a second, run. Right, it'll tell me that the first key is A. And now what I want to do is look through the objects to find the one that has a K of A, right? Just like the thing I see here. So how do we do that? I'm just going to comment that out, and we're going to go down to the next part of this, which is this find first element bit. This is really the key to the whole thing, right? Because I'm going to say I'm going to look over my list of objects, and I'm going to ask whether, and this has to do with the way these sort of iterator array functions work. There's a magic variable called this that's referring to the current item in the array. So it's going to look at each object of key value pairs, like the AX and the CY and the DZ. And this one's going to refer to the AX object first, and it's going to pull out the member of the object that matches the key name. Right, because we need to figure out which of these are the key, because from the computer's point of view, it has no idea what an actual key is. It just knows there are two members to it, K and V. And so we're going to tell it that we want to use K because that was the input that we got from the function. And we're going to ask, does that value stored to that key name K, in this case it's going to be A, we're going to ask, does that match the current member of the keys list that we're looking at? Does it match A? And then it's going to look at the next part of the object. It's going to ask, okay, does CY match A? And match A, and the answer will be no. First one will be the answer will be yes. Second one will be the answer will be no. Third one will be the answer will be no. But that's okay, because all we're trying to do is ask, does it have an element that matches? And it finds the first element and stops. So I want to know whether there's any element whether basically whether this key has a matching element in the object array. And if it does, I'm going to pull this match with the matching element, and I'm going to put it into output, right? So I'm going to say, first I'm going to try to find it. And then if it matches, I'm going to add it to my output array. And I just do that for each of my keys for A and B in the case of the little example I'm doing here. So it's going to look at A and look at B, and say, hey, A, do you have an object that matches A? I do have an object that matches A. That's what this guy finds. And then if it found it, it adds it to output. Now, second, it's going to look at B. And when B looks at this list of objects, it doesn't find anything, which means that this match returns null. And if it is null, well, then it won't add it to the array. That way we don't get nulls inside the array. The end result of this should be that this will give me a list of filtered, of just filtered objects, KV. So I would expect that given these 3 objects and given these 2 keys, I should get one result, which is where the key is equal to A. Try running it. That's exactly what I get. Now, if I were to say extend this list to include C, I get A and C. If I were to change it, I want to do D first. Note that also that the output of this is going to be based on the list of keys as opposed to being based on the list of the original objects. You, of course, can resort this or whatever you want to do with the data afterwards. I think this gives you a starting point for how to start to manipulate this information. In Xano provides you with lots of primitives to make it easy to reason your way through the whole thing. But of course, there are a few different moving parts, and hopefully you found this little tutorial helpful for identifying what those moving parts are in order to be able to do your more complicated matching in Xano.